everywhere. I'm going to tell you about the results provided by the references that we carried out with the modern flocks in the sheep and goats in the Catalan Pyrenees. The analysis of animal mobility is key to understanding pastoral strategies and animal husbandry regimes. In frame of the ERC Starting Ground project of Zone West, we conducted ethnographic work with present-day herders with organic herds in the Pyrenees. This work has been possible thanks to the collaboration of numerous institutions and researchers such as Leopoldo Pena and his team from the University of Barcelona, Nicolas Patris and Delphine Bosch from the Geosciences Lab at Montpellier, and Thomas Wett from Oxford University. But finally, a special mention to the farmers and sheep herders. Their involvement has gone beyond simply providing samples and ethnographic information about their herds. For 3 years, we have collaborated closely all the times, exchanging information, sharing the results, and collecting their ideas and suggestions to improve our work. As such, they appear together with us, co-authors of this work, at the same level, a fact that unfortunately does not happen very often in scientific works. Mobility has conditioned animal husbandry practices throughout the history. However, baseline studies with present-day livestock and plants are scarce. So the potential and limitation of strontium for tracking high-frequency movements for modern animals of no movement has not yet been fully investigated. This work aimed to provide and develop a relevant baseline for strontium and oxygen isotope ratios in the Central Pyrenees, along with an understanding of challenges and constraints linked to livestock mobility. We also want to delve into the current sampling protocols used in sheep and goat teeth to contribute to improving strontium isotopic reference for the study of past mobility. And finally, we also wanted to reflect on what it means to carry out ethnographic work with modern livestock keepers in Europe. Beyond the scientific issues, this work has made us aware of the difficulties that extensive livestock farming and local breeds are currently going through in the face of the growth of industrial livestock practices. Our study integrates an ethnographic and multi-isotopic analysis where strontium are measured in samples of present-day ecological sheep and goat herd, plants, minerals, salts, and water, taken in different areas of mountains and valleys of the Central Pyrenees, a comparison of different species and local breeds, sheep and goats, of 2 sampling methods and mobility patterns, local and transhumant movements, is also carried out. We have combined the live monitoring of the movement with the tracking and 2 geolocalization of transhumans herd through high-precision GPS devices of monitoring with geolocalization signal every half hour. The preparation of samples of teeth, slides and bands has been done at the Archaeological Laboratory of Institució Milà i Fontanals of CSIC in Barcelona, and strontium isotope analyses have been carried out by Lira Pantatalàs infrastructure in the University of Barcelona. And finally, oxygen isotopic analyses were done at the Geosciences Lab of the University of Montpellier. Reference work with present-day herds requires an important effort of selection and exploration together with a whole series of steps. Making first contacts, choosing the most relevant herds, accompanying and recording their transhumant and local movements, agreeing which animal could be used for the project, requesting permissions from the health authorities to access the slaughterhouse, preparing the modern jauns, and finally, sequentially sampling and analyze the teeth. No animals were slaughtered specifically for the purpose of the project. We respected the rhythm of each herd and keep a fluent relationship with the herders to ensure two-way knowledge transfer. In order to establish a reference with flocks of no movement, we are working with small and organic herds in an extensive regime. We have herds from 40 and 150 animals with local mobility, and herds of 200 and 500 animals with seasonal mobility over middle distances. Other than having a reference for isotopic analysis, we also wanted to observe and participate from the problems of real sheep-goats management in different mobility patterns. After having monitored eight herds for 1 year, we selected 2 for the study based on the geology of the area, animal management, and mobility pattern. The first flock had 550 sheep and 114 goats. The sheep move over medium distances. It's 50, 60 kilometers more or less during the summer months. We chose this herd because the 3 areas of which the sheep roam have distinct geological bedrock and was potentially optimal for tracking the different strontium signals. The same farmer also has goats with a different management as they graze in free range all year round in the valley areas, 5 kilometers around the pen. Both goats and sheep were tracked with GPS to characterize these 2 types of mobility management in the same flock. Only females were sampled as they have different management than males and are the majority in the flock. The second herd is The second herd is the first flock, the medium mobility, and is the second herd is specialized in goats with a total of 154 individuals. All of them grazed locally all year round within a perimeter about 5 kilometers from the pen. In this case, only 2 castrate males were sampled, which have a similar management to the females. We currently have a reference of 30 sheep and goats jaws from 5 different flocks. This study will be based on the analysis of 6 of them from the 2 flocks mentioned above. Regarding the sampling, we have applied the different techniques. You see the sequential sampling for the oxygen and strontium, 19 slides, it depends for the preservation of teeth, and 2 teeth per individual, M2 and M3. Slides, they have an advantage, samples easily cleaned, and the disadvantage, very destructive method. And bands, the advantage is less destructive, and disadvantage, weight of the sample is that the limb forgot reliability of isotopic ratios. Regarding the strontium results it's for 23 plant, 4 water and 2 mineral salt samples, allowed to restore the isoscape of the grazing areas of the studied herds. From these strontium isotopic results, we have made an isoscape, a distribution map of bioavailable strontium values, an interpolation with kringing with QGIS of the values for the point density has been done, which is the best adapted method to the sparse matrix when a low density of points is available. The results show a very robust north-south gradient with clear differences in strontium values between the areas analyzed. The greater diversity in bioavailable strontium values have been reflected in greater diversity in the tooth enamel of transhumant sheep. As can be seen in the dot plot above, goats that move locally have a significantly lower diversity in strontium signals. A noteworthy aspect is that one of the 3 transhumant ewes had the strontium isotopic ratios of the summer pasture in their dental enamel. The strontium results of the 2 goats from the local herd in the second study area gave the expected results. In this case, the bioavailable strontium is very homogeneous because it comes from the same geological layer. This density plot shows the strontium results of the individuals of the 2 herds and their isoscapes. it can be clearly seen that there is a direct relationship between the increased diversity of bioavailable strontium and the diversity of biopatite results from the teeth of transhumant sheep, as shown in the upper part of the graph. Goats grazing locally on a less diverse geological isoscape also have more homogeneous strontium values in their tooth enamel, as shown in the lower part of the graph. The results of the sequential strontium sampling of M2 and M3 together, and with the two types of sampling performed at bands and slice, the different sampling systems show it a slight mismatch between the slice and band samples in the case of the transhumant sheep. It seems that the bands show the changes movement a little earlier than the slice. They are more precise in the time. This may be due to the fact that the bands were made to the intermediate zone of the slice, and also that the slice make a bigger average of the strontium isotope ratios, as they include strontium values accumulated over a longer period over the time of tooth mineralization. Even so, the two types of sampling reflect the same trends regarding the sequential variability of strontium isotopic ratios. And on the other hand, the two sampling techniques overlap completely in the case of the goats with the local movement. In this slide, we present the combined strontium and oxygen results from the flock with the transhumans use. The oxygen curve shows a sinusoidal trend of seasonality in all sample individuals, but the highest oxygen values, summer periods, appears to be offset from higher strontium values, which correspond to the older geology of the summer pastures. These results suggest that the oxygen assimilation could be faster than strontium, and that therefore the same samples could be showing different assimilation times of the two elements. Another aspect to consider is the possibility that isolated M2 may not reflect this long medium distance vertical seasonal mobility. According to the farmers we work with, their sheep first go to the mountains when they have been between a year and a year and a half old, when they are considered to be physically ready. As it has been documented in previous works, the period of mineralization of M2 takes place during the first year of life, when these animals did not move yet. In this slide, we present the combined strontium and oxygen results for the second flock with annual local mobility. The oxygen curve of transhumant goats also shows a sinusoidal trend of seasonality in two samples individuals, but in this case, it has two more parallel and complementary tendencies with respect to the previous transhumant sheep. Okay. In the case of the transhumant sheep, we see that the strontium and oxygen curves intersect whereas in the local mobile goats they do not intersect. On the other hand, in the case of the goats of the second herd with annual local mobility, it can be observed that the strontium and oxygen curves do not cross but are complementary to each other and are kept a greater distance, a tendency that clearly differentiates them for the transhumant sheep. In conclusion, sequential sampling on M2 and M3 using both slides and or bands allows the characterization of seasonal movements of livestock and to distinguish them for animal grazing locally during the whole year. The results obtained on bands and slides shows that bands offer a more accurate view in the time. Still, the two sampling methods provide comparable trends. Although it has been proposed that the best strategy for measuring any geochemical proxy is the innermost enamel layer to minimize the attenuation of environmental variation. The current study demonstrates that band analysis also allows for high resolution of the strontium isotopic ratios and reconstruction of the strontium times series. Another important aspect is that the strontium isotope ratios from caprine and enamel biopatite may differ from that of the local geology. This was most evident on summer pastures. And finally, diversity in the strontium isotopic ratios along the tooth growth is a good indicator from the identification and differentiation between the long and short distance movement applicable to the study of archaeology assemblages. The final ideas and challenges is to go deeper into the problems that livestock farmers face when moving their herds around the territory. It is necessary to work with real herds, real management, and real problems. Involve farmers in research. It is not easy, but it's necessary and it's possible. It's necessary to be on the ground with a continuous and long-term monitoring made only possible by decentralized and research rooted in the territory. Local institutions hold the key to the articulation of future work with current referentials. In this is necessary to refine the methodological aspects, sample selection and digestion processes of the different types of sample for strontium isotope. We are working on it. And finally, archaeological research is not isolated from the current problems of society. It's necessary to create spaces for dialogue between academics, institutions, and livestock farmers. Archaeological research values and makes extensive livestock farming visible as an alternative to industrial livestock farming in the face of climate change and the current energy crisis. Thank you very much.